Dynamic programming is a method for solving problems by breaking them down into simpler subproblems, storing the results of these subproblems to avoid redundant computations, and building up solutions to the original problem from these stored results. The knapsack problem is a classic dynamic programming problem. Given a set of n items, where the ith item has weight wi and value vi, we need to determine which items to include in the collection, so that the total weight is less than or equal to the weight limit m, and the total value is as large as possible. The first thing to do when solving a dynamic programming problem is to define a DP table. We define the entry of dpij to be the maximum value achievable with the first I items at capacity j. If no items are selected or if the capacity is 0, then clearly the maximum value achievable is 0. Otherwise, if the weight of the ith item is larger than j, it is impossible to include it in the collection. Thus, dpij is equal to dpi minus 1j in this case. If the weight of the ith item is less than or equal to j, then we can include it or not include it, and we should take the max of the two corresponding values. Vi plus dpi minus 1 j minus wi is the max value we obtain by including the ith item. dpi minus 1j is the max value we obtain by not including the ith item. Here is an implementation of the solution to the knapsack problem in Python. We initialize a DP table with all entries set to 0 and then use a double for loop to compute the entries. The final answer is dpnm, and we simply return it at the end of the algorithm.